Good evening. Welcome back to mobile development, mobile software application development, something like that. This class is about Android development anyway. One of those things. Welcome back to it. Today I'm going to share with you my feelings about mobile development. We're not diving into all the nitty-gritty just yet because first I want to be upfront with you about this because that's how the semester will go. Obviously, you're going to have to be working on this a lot, and some of this might not become apparent until a few weeks in, so I want you to know kind of in advance what this field is like before you commit to it as a course. And then the second reason why we're doing this today instead of going right into the code is to give you a chance to get Android Studio set up and get your device connected to Android Studio. So hopefully you have both of those things done completely by next week. So I expect that you've got your Android Studio installed and your device hooked up to it. Aside from telling you how to enable developer options, I really can't give you a ton of advice on how to set up your phone. I've had it go as simple as just plug and play. Like I've gotten the USB cable, I've gotten the phone, I turned on developer mode, I turned on USB debugging, I plugged it in my computer, and everything works. That happens on maybe like 75% of the phones that I try, and then there's the other 25% where I've got to download some weird ratchet drivers, I've got to play with some settings, I've got to go into the USB settings on the phone. That's happened too. I think the worst experience I had was with a budget Samsung phone that required you to install like Samsung specific software and drivers in order to get it connected. But anyway, I'm saying it could be a struggle. It could be nothing at all. If you've already connected your phone successfully to the computer, I'm going to take a little poll. Connected phone to computer, let's say in Android Studio specifically. So, of course, connecting it to the computer for the computer to go doo-doo and recognize that it's read it is one thing. Actually getting it to read in Android Studio is sometimes another thing. It depends entirely on how compliant the OEM is. So that should be your first clue that this can be a real headache. This whole industry can be a real headache at times. That's as complicated as it is. And again, I really can't, as much as I'd love to, I really can't help you much with it because every phone OEM is different. I can walk you through that process for enabling developer mode if you're having problems with that. Other than that, you're probably going to have to search for your particular device and how to get it connected to USB debugging. So basically what you're searching for is your particular device and USB debugging, or your device and Android Studio or something like that should give you the kinds of results that you need. Okay, without further ado, let's get into the wonderful world of Android development. What is it like out there in Android land? Hopefully none of these slides are cut off by your decision not to have the black bars on the side. Let's see. Alright, so mobile's terrible. Seriously, it's terrible. It's a terrible ecosystem. It is a very toxic environment for small developers that is made altogether the more toxic by the fact that it wasn't always this way and that the major operating system organizers, so Google technically doesn't own Android, it's open source, but they're certainly the ones most in charge of its development. Apple obviously owns their operating system, but same story for them, sometimes even more so. Both of them courted indie developers and small developers extensively early on in their platforms development, and they had numerous indie and small teams generate the big ticket popular apps of those eras, and then at a certain point they both decided to say forget the little guy, only enterprise devs on our platform to the extent where I would say now developing for mobile is actually harder than developing for the traditionally high barrier, enterprisey considered platforms like developing directly for Mac or developing an app directly for Windows. Mobile is the big headache, and most of the indie devs today have moved on to web or something similar, because that's where they can actually work and not go insane. That said, mobile is still a sustained source of income for enterprise developers, because practically every company needs some kind of mobile app now, be they a bank or a tire change place or a restaurant. Everybody and their grandmother has a mobile app. Most of these small, tiny mobile apps are nothing more than information trackers appended onto a very simple template with the company's name on it, but nonetheless somebody does have to develop all of that stuff. I'm sure all of you can look through your app drawer and see the tons of different apps that you've gotten for every taco place that you go to or whatever else you ended up installing for one reason or another. So what makes it particularly bad for small developer and particularly good for enterprises is that things change all the time in mobile for seemingly no reason, and it breaks your apps. That's the number one complaint that I think anybody who's worked in the mobile world for any meaningful length of time will voice. It's true for both iOS and Android. Things will just change, break your apps. There's seemingly no benefit to either you as a developer or certainly to your end user, but it requires you to have to conduct maintenance. Now, if you're a salaried person working in mobile development, that's awesome for you, because otherwise what happens when your app is finished? They don't need you anymore. Whereas now, they're going to need you forever. As long as they need a mobile app, they're going to need to keep developers on, because those breaks will happen randomly. They can happen any day. Android can just decide, we're going to update to Android 13 today, and Android 13 is going to discontinue these 5 major features that your app depends on. Good luck. And then what are you going to do? Not support everybody who has the latest Samsung and the latest Pixel? Those people are going to be some of your best customers, so that's not really an option. You got to go back to the drawing board and fix it as soon as possible. So we've seen basically since its inception radical changes to the Android platform and to the iOS platform almost annually. We've seen sweeping changes rolled out on a regular basis that have basically ruined everything for small-time developers. And I'll go into a couple of examples in a bit here. But okay, that's the big picture for why mobile is terrible. That's the biggest complaint. So you might ask, all right, who's better, Apple or Google? They're equally terrible. Out of 10, I give them both like a 1. They're great companies in general. They make a lot of wonderful products. They make a lot of wonderful systems. There's nothing wrong with Android. There's nothing wrong with iOS. They both work very well. They both have good app stores. The problem is being a developer for them is a miserable experience. Actually, being a user of both of them these days is also kind of a miserable experience, because the app store for both platforms is a cesspool, right? Finding a decent app on either the Apple or the Android app store to do something is a real burden. Most people, I would say, use the majority of the time the same big apps from big companies. They don't really install a lot of small-time apps anymore. And the reason that you probably stopped doing that, or you never did in the first place, is because your app store is probably a cesspool. Nonsense. Android greater than, somebody said. All right, so to counter this, if you have an app on your phone that you think doesn't come from a major company and you think it's not bad, please put it in either chat. So if you have an app on your phone that doesn't come from a major company and you think it's not bad, like you actually use it on a regular basis, so not Snapchat, not Instagram, not Facebook, not your web browser, an app that doesn't come from a major organization and didn't come with your phone, name it in either chat, because it's rare, right? Where it used to be something that people had all the time. They'd have a bunch of little apps from little crappy developers. So once mobile was the market of the indie developer, and now it is not. And let's look at a couple of the reasons besides what I already said that it's not. First, the major OEMs and the major OS developers and basically everybody are pushing us into a world where either you use the cloud services provided by them or somebody else, or you simply can't do anything of value. They accomplish this basically by pushing security requirements and other various requirements onto your apps that make it very, very difficult for you to self-host your content or do a variety of tasks locally, which forces you to migrate those tasks remotely. It's very hard to host your own services and basically be allowed in the App Store. So you end up kind of being siloed into the cloud service providers to do anything of value. Cloud service providers are very scary for small companies, very scary for individuals. Anytime I use a cloud platform, I live in constant fear of getting that $1,200 bill at the end of the month because I accidentally made a typo, and instead of for I equals 1, I said I equals 100, and it accidentally makes 100 requests a second, and now all of a sudden I've racked up thousands of dollars in cloud usage. You'll notice that all of the major cloud providers give you the opportunity to set a limit, and after that they'll email you. The funny thing is anybody who's ever been burned by this knows, you'll get that email well after you've spent the money. It's too late by then. The cloud bill has already become the bill, and you might be able to ask their customer service very nicely to get it pulled. But besides that, you basically stand no chance. I've noticed nobody has given me the name of an app they use that's not from a major company yet, so surely somebody has one good one. I want to have at least one example to pick on, so try to come up with one. Well, search through your app drawer on your phone, see if you can find something that doesn't come from big tech. So basically everything requires you to use cloud services, and it's very easy to get burned. API calls that used to be very affordable sometimes get big price hikes, sometimes overnight. Google famously hiked up the price of the Google Maps API by 1,000% overnight with effectively no warning. So you were paying about 50 cents for every 1,000 API calls to Maps, and then the next day, all of a sudden, you're paying $7 for every 1,000 calls. Let's say you made a very successful app that depends on the Maps API, and you make your revenue model, you make, let's say, $2 off of every 1,000 API calls from your users. Okay, you were making $1.50 in profit on Thursday. On Friday, you're losing $5 per 1,000 requests in money. So you went from being profitable to well in the hole basically overnight just because the price of one of your underlying services went up. Things like this happen all the time in the mobile ecosystem. I pick on Google there, but Apple's equally guilty. Somebody said Tarkov Battle Buddy. Okay, kind of a small company. I'll give you that. Self-Care, also kind of an indie thing. Both of those are good examples. So there are a couple of apps out there. Keep thinking of more and realize that if you want to have any chance basically of being on somebody else's device, you're going to need to emulate these. Obviously you have no chance of emulating, say, a Tarkov app because it's connected to a game, right? So life counters, trackers, to-do lists, those kinds of things are still fairly popular in the indie sphere because there hasn't been a big tech kind of competitor to those that has been very successful. So those are good ideas for your app. Things that are like lifestyle applications, still very possible to be successful with those in the indie sphere. And someone said like a guitar chord kind of thing. Another one of those things is very niche. Those kinds of things are also often able to be successful. So basically think small and think niche, and you've got at least a fair shot of being successful to a degree. Now, even if you've gotten past all of that, so you've paid for your cloud services, you've paid for your API calls, now all of the money that you make on the App Store, you've got to give a whopping 30% to either Google or Apple. That is a massive cut, the likes of which is unseen pretty much anywhere else. It is a very big slice of the pie. So whatever money you're making off your app, you're living off of 2/3 of it, because the other third is going to go directly to the store. That's unfortunate. And if you're on either of those platforms, you don't have a lot of choice. You really can't not use the store. On Android, there are alternative stores, but I don't think anybody's really making any meaningful amount of money on those, aside from developers in China that use the Chinese alternatives. And then the rules. Oh man, the rules. The rules might be the worst part. Even if you can get past all the random changes and somehow manage to cobble together a functional app and maintain it, sometimes your app just gets disappeared. No reason. And I'm not just talking about big ticket political bans like Parler, although that obviously made the media headlines recently, and people feel either way about it. But for every Parler, there's 1,000 or 10,000 indie developers who got banned in silence for something that they're not even particularly sure about. You'll get a very generic email about having violated the terms of service and having 24 hours or 7 days or whatnot to comply. You'll probably do your best, and then you'll probably get ripped off the App Store anyway. Someone said Parler's the worst app. I don't know. I never used Parler, but by all accounts, from a security standpoint, it's not great. But what I want to say is you don't have to stir up political controversy to randomly get your app pulled from the store. It can randomly get pulled from the store for any variety of reasons, including no reason at all, or a reason that you barely have any conception of. Do you have any chance to appeal in that case? No, not really. The removal of your app is typically automated. It's virtually impossible to speak to a human being about it. Your best chance of getting reinstated is often just to whine on social media and hope that somebody from Google notices it, or that you have a friend from Google and they notice it, or obviously Apple in their case. Otherwise, you have essentially no chance of being reinstated. And whining on social media obviously isn't a sustainable way to appeal your app being removed. So I have personal experience with the random and capricious nature of the App Store. I have an app up there just for research purposes that doesn't really do much of anything. It's very bare bones. And at some point, randomly, they messaged me and said that I had 7 days to add a privacy policy, or it would be removed from the App Store. So, okay. I'm a developer. What do I know about writing privacy policies? Tough shit, write one. All right. So I go on the internet. I find a nice looking generic privacy policy, host it somewhere. Everybody's happy. All right, fine. Then another message. You're collecting an advertiser ID and not disclosing it. Got 7 days. Your app's going to be removed. Okay. I don't know what that is. I don't know how I'm collecting it. My app doesn't have any ads. But all right, fine. I'll add a disclosure. So I add a little line in my privacy policy. All right, great. Reinstated. I think I go through, just from having the app up on the store with no updates, I go through at least one warning a year telling me that it's going to get taken down because I violated the terms of service. That's on a bare bones app with no updates. If you're actually doing something, boy, I don't even know. I don't know how you get by, because it's definitely going to be difficult. And then every once in a while, your app will be chugging along doing something that is permissible, totally allowed, everybody's happy with it, and then all of a sudden Google or Apple decides that the thing that you were doing is not allowed anymore. The big example, which I'll bring up later, is call recording. So for a very long time, until Android 8 or 9, call recording was permitted. Recording calls is obviously legal in every jurisdiction in the United States except the People's Republic of California and a couple others. And even in California, it's legal in set circumstances. So it's not necessarily an issue of legality in the United States. It might be abroad, but I don't see why that would affect the U.S. cell phone market. So they were fine with it until overnight they weren't, and they removed all of the APIs that allowed call recorders to work, which means that all call recorders in the App Store, including the one that I paid good hard American currency for, stopped working. Do I get a refund? No. But that's the way it is, I guess. You just lose your permission to do so, and the developer that worked on it basically has their livelihood yanked out from under them. So even when you follow all of the rules change, and they change often, and they change in unpredictable ways. And of course, reading the entire terms of service is practically impossible. Features then. Since I mentioned call recording, let's talk about some features. again, it was there, and now it's not. So you could do it, and now you can't. Accessing device memory, you used to just be able to read and write to the device memory basically pretty freely, and that's kind of an expectation in Java, right? That you can just write to the external memory. Let's say you just want to write a text file to the file system, a very basic thing that you might want to do. Now only in extremely limited circumstances, and just doing it is considered a dangerous privilege that gets your app flagged for extra review and can get it taken down from the store in many instances. So just writing a text file or reading a text file from the local file system, now considered a dangerous thing. How about sending notifications? One of the most basic and essential features of a smartphone application. Being able to update your users that they need to do something or another. How about that? Well, now, this isn't actually Google's fault. This is more of OEM's fault, which gives you another layer of where things can go wrong. Sending notifications is practically impossible. You need to go through this very elaborate 10-step process to do so. It brings you websites like, let me pull it up here. It brings you websites like this one, don'tkillmyapp.com, which rates the different smartphone OEMs based on how good they are at letting your app survive in the background, which is essential for being able to send notifications. You'll notice OnePlus, Huawei, Samsung, and Xiaomi, which make up the majority of the smartphone market. Again, remember from last time, those are some of the top manufacturers, right? All get a very large number of thumbs down, meaning that even as the end user, it's practically impossible to tell your device, please let this app live and actually send me notifications. As the developer, you just can't do it. If the person who downloaded your app isn't technically savvy, the default method of making notifications is not going to work, and you are out of luck. You're going to have to go through a very elaborate process to get them working again, which is something I will describe for you when we get into development, because, again, this kind of behavior from the OEMs, it comes from almost all of them. And so basically every major smartphone manufacturer ships with, in this case, a battery life manager that kills your app in the background and makes notifications not work, and that you have to find a considerable number of ways to get around. By the way, if you're wondering how apps like, let's say, Instagram and Facebook and all of those are still able to send notifications, again, in an even more small developer hostile move, those different OEMs with their aggressive battery manager that kills notifications all ship with a whitelist that makes it not affect big name apps that the users would actually care about. So as an indie developer, you have to deal with the fact that you have zero chance of ever making your way onto that whitelist. So you have to work around it. Whereas the larger companies, Facebook and their subsidiaries, Instagram and WhatsApp and Snapchat and whatnot, those are automatically whitelisted, and their notifications will go through because the smartphone manufacturer knows that their users are going to get upset if those don't go through, whereas nobody's really going to care, and they're just going to blame you if your app's notifications don't go through. USB access is another one. You used to be able to use your Android device to do various things on the USB connection, which you just can't anymore. And this is something that a lot of developers were making really cool things with, to talk to external USB devices, connect your phone to external USB devices and command them, do different things with them. Nope, it's gone. You just can't do that anymore. You can downgrade your Android version or buy an old phone, but that's about the best you can do. And again, hardware OEMs do what they want. Obviously less of an issue with Apple since they make all of their own devices, but even Apple sometimes decides to completely change the way that they're going to do things. Apple, for example, will completely change the form factor of their device. They can change the shape of the screen. I mean, despite the fact that there's really only one iPhone, it comes in different aspect ratios for some reason, which makes you have to support different sizes. Okay, I guess that's fine. They will remove things like the navigation bars. Everybody remembers when Apple transitioned to gesture-based navigation. Well, as a developer, okay, you were relying on the navigation bar, now it's gone, so now you have to go and implement gesture-based navigation. Is it good for the end user that they have a consistent experience on their phone and that they can use gestures everywhere? Sure. Is it annoying for the developer to have to go back all of a sudden and implement those kinds of things? Yes, very. Different security features on Apple that keep changing as well. Even the way you sign in to your iPhone has changed from generation to generation, from PIN to fingerprint and then to Face ID. If you rely on those kinds of sign-in platforms, that stuff can change. Even Apple has undergone technology changes. But this is worse on Android, obviously, where there's lots of different manufacturers. On Android, the manufacturers vary widely in how they implement exactly the same feature. So if you're using a system-level feature, something like, let's say you're using the size of the user's finger when they touch the screen. That's something that you would probably want to use for, let's say, a drawing app. You want to just build a simple app where people can draw on the screen. The way that different devices report that, so the way a Samsung versus a Huawei versus a OnePlus versus a Xiaomi report it, is completely different. So Samsung has maybe decided that the size of the finger ranges from 0 to 1. Okay, whereas Xiaomi decided it ranges from 1 to 10. And OnePlus maybe decided it ranges from 5 to 15. They just picked arbitrary ranges, and now you have to have this complicated switch if statement block that determines what device the user has before it decides what size to make their finger for the actual drawing thing. It's a very complicated mess when things like that happen. Different things like opening the camera vary by device manufacturer, so again, you end up with these big blocks occasionally of if statements checking the manufacturer of the device before you can figure out what you need to do for that particular device. Remember, part of your score in this class is getting your application to be store ready. Store ready means it works on most people's devices. One of the things you're going to do during the peer review phase is to make sure that other people's app works on your device and give them feedback about the things that are broken on your device. And then I encourage you guys to work with one another to test each other's apps on your different devices to make sure that they work on your different devices. When we get into development, I'll show you how different an app can be on the few different devices that I own. And then I already mentioned the battery managers. Obviously, this is one of the most annoying features this generation. If you've got a Samsung, OnePlus, Huawei, Xiaomi, whatever, go into your settings, look at that third-party battery manager and see all the tiny little indie apps that it's murdered in the background. So do you like learning new programming languages? Are you the kind of person who every time a new programming language comes out, you go, yeah, I'm going to get on that immediately? Well, great, because that's what mobile development is like. The mobile development is so complicated that it changes language completely without very little notice. Java to Kotlin in Android's case. Android just suddenly, Google suddenly just announced... not just, but let's say a year or two ago announced that we're going to make Kotlin the official language of Android. Let's do a quick poll here and see if you've heard of Kotlin. You know, obviously before this class, I've mentioned it already a couple times, so don't say yes if you just heard of it in this class. Most people would have probably answered no before Google suddenly decided that it was going to become the language du jour. There are even situations now where it's unclear whether Google is going to continue allowing Android to move forward with its native UI development or if it's going to go somewhere else. I'll talk about that some more later. But these language transitions are sudden. They require you to learn a lot. The build tool for Android Studio is Gradle. Gradle has changed languages too. I think it was in Groovy, and now it's in Kotlin 2. All of these different things change very frequently. The fact that you have to use a build tool at all is pretty complicated too. Now, you can still write apps in Java for now. At some point you won't be able to, though, so you're probably going to have to rewrite it. It looks like Java might be continued indefinitely, but at a certain point they're probably going to stop offering it as much support, and then eventually that rewrite will be inevitable to keep your app working. So ostensibly they're going to support Java maybe forever, but at a certain point it's probably going to be very difficult to get it working. Apple did the same thing by deciding that Objective-C is dead. We're all moving to Swift, and they gave barely 3 years notice of that. 3 years sounds like a long time, but it's really not. It probably took a long time for most people to get the memo, and it really does come up on people practically overnight. But of course, that's a lot of developer jobs that got made from people that had to convert things from the old language to the new one. And a lot of people got to learn new skills. Both Kotlin and Swift are very nice languages. They're definitely cool. They have a lot of nice features and syntax and all that good stuff. Are they better than Java or Objective-C for 99% of developers who are using them? Probably not. Probably basically the same thing, and most people probably don't care. There's definitely use cases for both of them where they're much better, but for the most part, it's just an extra thing that we all have to learn, unfortunately, and that's definitely annoying. The worst part about these kinds of transitions, though, is that they wipe out all historical information about the entire platform. You can no longer Google anything about iPhone development because the results you're going to get are going to be in Objective-C, and they're going to be useless. And sites like Stack Overflow do a pretty bad job of archiving dead languages, so a lot of the time when you search for how to do things, both in Android and in iOS, you get results that are no longer applicable because that language doesn't work anymore. The worst part is that it splits the ecosystem for the search in two. So sometimes you'll search for how to do something and you'll find an answer in, let's say, Kotlin. Then you search for how to do another related task and you'll find that answer, but in Java. Now you have to do the added burden of converting them. So you either have to convert the Java one to Kotlin or the Kotlin one to Java. Luckily, Java and Kotlin can coexist in the same application, so you can sometimes bludgeon them together like that. But they can't exist in the same class. So if it's something that you were going to paste into the same class, sorry, it's not going to work out. You're going to have to make some conversions. Anyway, very rough to work with big language changes like that. Now, welcome to peak object-oriented programming. If you're a fan of object-oriented programming, if you like design patterns, and you like basically all the OOP principles, then you're going to love Android, because Android is so OOP, it's almost a parody of OOP. It is hilarious. And Swift, for the most part, is not a parody of OOP, but it is odd. It's unlike most other languages. It really is quite different, and you'll see that a lot of people who end up being Swift developers, they basically stay in Macland and don't leave, and a lot of that is because Swift is kind of hard to pivot in or out of. Android has things called views, fragments, contexts, activities, and layouts. What are all of those different things? They all kind of sound like the same thing, don't they? What's a view versus a fragment versus a context versus an activity versus a layout? Those are all different objects. Android has hundreds of such funnily named objects, and you just have to know what they are. So you just get to learn what all these different fancy objects are. There will be a great deal of them that you're going to have to learn. Android got split into two libraries. It got split into the support, also sometimes called the Compat library, and then the regular native library. And then they decided that they were going to discontinue the Compat library. This happened very recently, by the way, only about a year ago. They decided they were going to discontinue the Compat library and migrate everything over to Android X. So now you have three libraries. When you make, let's say, a fragment, so in Java, when you make, let's say, a JPanel or something, you get to import java.auth.jpanel at the top. When you make a fragment, You get three options in Android, essentially. You can import the native version, the Compat version, or the Android X version. Sometimes they play nice with one another, sometimes they don't. Sometimes one has a feature, sometimes another one doesn't. Sometimes they're exactly the same, but one plays nice with other Compats and one doesn't play nice with other Compats. Sometimes one will work on a legacy device and other times it won't. It's really quite a mess to decide which of the three virtually identical libraries you have to use. You have to be essentially a wizard to figure it out in most cases. My hard and fast rule is just to pick whichever one it suggests to me first and then roll with it. Mostly I've been using the support and Compat library though, and now that it's been discontinued, I also am not exactly sure what I'm supposed to do. So we'll see. I guess all of the apps that I make in this class might stop working. Or I'll try to migrate to Android X again, which requires me to have to learn how to do that. Which is the now second time in the last 2 years I've had to learn how to use a completely new library because they pivoted from native to support and then to another thing. So in addition to a language pivot, they've also done a library pivot for extra annoyance. The goal of this extra support library type thing was pretty noble. They were trying to make it so that you only had to write one set of code that works across all the different versions of Android. So you can write one set of code that works for basically 7 up through 12. It will implement the version 7 version of what you're trying to do for that, a version 12 version for what you're trying to do for that. Most of the time this works quite well, but a lot of the time you still end up having to say if version equals 7, do this, if version equals 12, do that. And of course, the class hierarchy that results from having these different APIs is very hard to follow. What I mean by peak oop too is that a lot of the time you'll end up with these crazy statements in Android like object.getObject.getInstance.getContext.get.create.initialize. Those are statements that you'll routinely see. Kotlin, I hypothesize, was basically invented just to make these statements shorter through the use of lambdas and things like that. Kotlin is able to infer a lot of these silly little arguments and make those statements shorter. So that doesn't make them less complicated, that just hides the complexity behind syntax. You'll still regularly see very, very deep object calls like this. You'll also see a ton of different factories, variables that come out of nowhere, like you need the view, you've just got to type get view, you need the context, get application context, things that you just don't know unless you know them. So you have to type this dot application context, that comes out of nowhere. How was I supposed to know that that's how I get the context? Well, someone had to tell you. That's the only way you can really find out. Or I guess you had to see it in an example, because it's definitely not intuitive. You'll see a ton of factories and singletons and other design patterns, which is good if you're trying to learn about design patterns, which most of you are. So this can teach you a lot about object-oriented programming, a lot about how it gets annoying, and a lot about where it can be good, a lot about what is going too far. So in terms of the actual experience, you're going to get, a pretty fair amount of experience. Someone asked, is there a class that came before this? So really you just need the basic OOP course. It would help to have taken 328. You should at least be taking it this semester. But that's really just to refine your Java skills. We're not really going to need any of the 328 concepts. But some of this stuff, if you've only taken the basic OOP course, the idea of 5 deep object.getObject.getObject.create.initialize statement can seem very daunting indeed and very hard to follow. It's nothing more than basic OOP applied repeatedly, and the factories and singletons you won't have learned about unless you took the design patterns course, which hasn't been offered in a while. But it's your opportunity to get to learn about some of those things because you have to use them to accomplish various Android goals. Good news is you don't have to understand them necessarily. I'll just show you the application for it, and once you've gotten it, it's pretty straightforward. So, do you hate reading documentation? That's good, because Apple and Google have hardly any that's worth reading. Swift's documentation is one of the worst out there. I best describe it as mostly blank. Most of the things that you go to look up in Swift, it'll just be the auto-generated documentation and nothing else. It's truly quite awful. Luckily, we're not doing much in Swift. We're actually not doing anything at all in Swift, so you don't have to deal with that. Swift has good video documentation, but of course videos require you to listen to them, and to find the part that's relevant to you, you might have to comb through 50 hours of video, and that's not ideal at all. So with Swift, if you want to get started, you basically have to follow the video course and learn everything, and then you can get started. Android has a lot of documentation, but the documentation that it has is simply awful. It's, first of all, very, very long. Just to do the simplest thing, it gives you this preamble of all this other crap you don't need. There's always tons of extra information whenever you're trying to look up any even tiny minor thing. But that might not even be as bad as the fact that many of the documents are wrong. I'll routinely find basic mistakes in Android docs, just typos, things they've omitted that make it not work. They'll be missing a value here or there, or they'll be using methods that are depreciated or outdated, so they don't even work on the new devices. There's just so many problems with the Android documentation. The Android documentation gives you a lot of suggestions, and those suggestions are often wrong too. It'll say, like, you must run this before you run that, and that'll be wrong. You actually have to run the second thing before the first thing, and you just figure it out by trial and error. Sometimes the suggestions will be conflicting. You'll see one documentation that tells you have to run X before Y, then you'll go to Y's documentation, it'll tell you have to run Y before X. Okay, well, what do I do then? Or it'll tell you, never do this. And then in another piece of documentation, it'll do it. And then it's like, well, okay, what do I do here then? Do I copy this or not? Because everything keeps changing, the way that you do things keeps changing. But the documentation evolves, I guess, slower than the actual code does. So sometimes tracking down what to do for your particular version of Android is impossible because it hasn't been quite documented yet. More often, it's just really hard. So you find how to do something in, say, version 7, but it's completely changed in version 11. Tracking down how to do it in 11 is not easy. Let's look at an example, actually, just because I think it's interesting. I'm not going to cherry pick one, too. I haven't pre-searched this before. I just guarantee that this is going to be incorrect somehow. So I'm going to look up, let's say fragments. Let's look up how to use fragments. You see I've actually got a purple link there, so I must have looked this up before, but it was in the top of my mind, so I'm going to look up how to use fragments. It was last updated November 23rd, 2020, so this seems pretty recent. So what do I mean about a bunch of extra stuff? So Google's committed to advancing racial equality, then a description of fragments, then a note that's irrelevant to me, then some stuff about how fragments work, and then some more stuff, and then next steps, and then some comments on how to use them. There's no code here yet, so okay, I want to create a fragment. Let's go to create a fragment. Oh boy, look at that. I need to set up my fragment library first. Okay, so I need to add this repository to the build Gradle. Okay, hopefully I can find where that is, since you haven't told me. Then to include the Android X fragment, I need to add the following dependencies to build Gradle. Okay, seems good, except they've said fragment version here, and I don't know, is it 1.2.5 the latest, or is there a newer one? What's the date of this page? I have no idea. Okay, so we get to the code samples. We've got our Java version, which you can see is longer than the Kotlin version. Oh, look at that nice familiar Java version. It also provides more specialized fragment-based classes. Yak. Adding a fragment to your activity, adding a fragment via XML, adding a fragment programmatically, etc., etc. So quite a bit of extra information here. And then we get to the code, and we see a little bit of an example of that object-oriented craziness here. So, how are you supposed to know this? Get support fragment manager. That comes out of nowhere. That's one of those factories or singletons. There's one support fragment manager that runs for all things. You get the instance of it. You just have to know that. All right. Begin transaction. dot set reordering allowed, dot add, then the name of your fragment, then dot commit. That's 1, 2, 3, 4, 5 deep object call that relies on a singleton that you just had to know existed in order to use it. Then none of what just happened there is described anywhere in this documentation, really. And it says see also. So it gives you that the page was last updated 2020 11/26, but I guarantee almost that if you copy this code into your Android Studio, maybe we'll give this a shot later, I'll leave this page open, at least something here is going to be marked as depreciated or outdated or something. I would bet pretty fair that that's the possibility. But anyway, you can see it's very, very wordy and not telling you particularly much about what you actually want to do. There are third parties everywhere in Android, which is both a good and a bad thing. The bad part of that is obviously that the API just isn't strong enough to do really basic things. Apple users, for example, might laugh at the Android peasants because Apple has long had a QR code reader in their camera app, and Apple gives you the ability to call the QR scanner as a thing in the system. It's in the API, whereas on Android there is no built-in QR scanner. Despite the fact that it's 2021 and QR codes have been used for ages, you have to depend on a third-party library to get QR scanning to function on Android. That means that you have a third-party library to deal with. Now, of course, you can say, well, just write your own QR code scanner. Yeah, that's probably outside the realm of most people's capabilities, or at least it would take you a very, very long time to do it if you're just trying to make a simple thing. And this is true of a lot of other stuff that probably should have been built in. Things like network requests. You can use Java's built-in network operations sometimes, but that's not the recommended way to do it. The recommended way to do it also isn't very good. There's another third-party library that's better. This is the story for a lot of simple, well, what you would consider relatively simple features in Android. You've also got things like database interaction and dependency injection that a lot of developers consider pretty essential to making applications that don't really come with Android in a meaningful way. Google offers tools to do these things, and then those tools aren't necessarily the best, or there are third-party options that are better. Simple tools like barcode scanning, color picking, again, those you need to rely on third parties as well. Build tools. So Android, when you make your Hello World project, so you just start up Android Studio, make a new project, it's got nothing in it. It'll have over a dozen files just for the starting Hello World project. It's very daunting to run into that. Now, it will run right from the get-go as long as your phone's properly set up and everything, like plugged in and all that. You can run the blank Hello World app. But the fact that there are so many files created is very daunting. And the fact that you have to touch those files pretty frequently is even more daunting. So Android uses Gradle, as I mentioned before, a skill that's very useful to learn because out there in industry, most Java developers are using either Maven or Gradle for their build tools for major applications. So you're picking up Gradle. Once you've mastered Gradle, moving between that and Maven is not that big a deal. So this is a very helpful skill to have. It's also very good to at least be able to talk about Gradle. If you're asked during an interview, have you ever used build tools, you'll be able to say yes. So this is good experience to pick up. But working with these build files is frustrating, especially when you just want to build something really simple. It's much easier to just like add jars or something like you do it in Eclipse. At least for simple things it is. So you've got, in a brand new Android project, you've got a manifest, a layout, a values with different things in it. That's a folder. You've got your build.gradle and other things in the Gradle folder. You've got metadata like the git ignore and stuff. So Hello World becomes a pretty daunting task. Tinkering with Gradle and the manifest is going to become essential very quickly, so don't think you're going to avoid it. You're going to have to edit the manifest and the build file as well as you go through the semester. You will have to edit the manifest almost right away for anything of meaningful complexity, and then you're going to have to play with Gradle too, as you have to add third-party dependencies and things like that, and definitely to build your app to the store. You're going to have to mess with both of those things. And of course, there's the development environment for Android. Android Studio. Android Studio is the only IDE that I know of that manages to be slower than Visual Studio. In fact, I find Visual Studio to be wonderfully fast ever since starting to work in Android Studio. If I compare the two side by side, I think even if I give Android Studio a big head start, it's going to get demolished in start time. I guess we can give it a go. Let's see. I'm going to give Android Studio a head start, and we'll see who wins. I give Android Studio a pretty big head start. Visual Studio is already open, basically. I'm going to go to like just some random thing. Oh, look at that. It's already loaded my project. Android Studio, still thinking. Visual Studio is already done. I gave it a massive head start and didn't even click ahead of time, so that lets you know basically how slow Android Studio is by comparison. Eclipse just looks like lightning compared to both of those, but compared to Android Studio, Eclipse just blows it out of the water. If you have less than 8 gigabytes of RAM, I wouldn't even bother. Android Studio will crawl. Those of you who are trying to program on a laptop, get ready to hear those fans blast up. And if you don't have an external monitor, I recommend grabbing one, because the Android Studio window, as you might have seen, is quite tiny. You don't necessarily need one, but on a small screen it can be a pretty bad experience. And obviously, if you like menus, this is the IDE for you. I mean, you got menu, 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 and then a bunch of different boxes everywhere, boxes on boxes with buttons, and more buttons, and more buttons. If you counted the number of buttons on this basic startup screen alone, I think there's probably something like 100 buttons here, just of different kinds on the default startup screen. It's a lot of buttons. And that brings me to the big app stores, the other, I guess, development environment that you have to work for. So we've all used the big app stores. We know they're filled with mountains of junk and knockoffs. We know that the odds of any particular app making it to the front page organically are very, very low. I already mentioned the 30% cut. There's also an annual fee for Apple, $100 a year to be in the developer program. For Google, it's a $25 fee one time, but still, you have to pay just to get started. You can, instead of targeting the Google App Store, target F-Droid. I definitely encourage you to do so if you think that you're up for making a free open source application. It's not any harder than targeting the Google Store. You just have to commit to only using free and open source dependencies, which isn't that big a deal. So if you prefer, instead of going to the Google App Store, go to F-Droid instead. That'd be great. I think a lot of the apps that I use, a lot of the best apps on my phone, come from F-Droid. Apps for reading social media and stuff, and basic things like QR code scanners and flashlights, and basic things like messaging tools or location tools. All of the best versions of those are generally on F-Droid, in my opinion. And then, of course, if you want to make an app that targets rooted phones, that's probably the way to go as well. And I guess I should mention the job market too for mobile developers. So because mobile is so accessible, especially Android is so accessible in the international market, you can get the phone for relatively cheap. You can power through the development cycle. Because that's possible, the language barrier is low, I guess. Android in particular is a market where there's a lot of international competition that really drives down the wages. So you'll see a lot of development companies for mobile in other countries, in East Asia, in Europe. They definitely put downward pressure on mobile development salaries. It's, I guess, considered a lower tier of development because it's, I guess, considered easier. I don't know. But the salaries are lower, particularly at the entry level. It can obviously be pretty stressful to work in that field because you're going to be subject to hard crunches when those aforementioned random changes create random breaks, and you've got to fix them as soon as possible. We are all probably familiar with even mainstream enterprise-grade apps experiencing multi-hour or maybe even multi-day outages after an update. You can imagine what the developers at those companies were doing, scrambling around trying to get it working. That's going to be pretty typical. You're going to run into a situation where there's a multi-hour or multi-day outage, and you're going to have to run crunch to solve it. And of course, the market is unstable since you're subject to random layoffs when apps are discontinued or outsourced to those international companies. You'll see apps get redesigned and changed massively, things like your banking apps or other apps for companies you work with. I'm sure everybody's familiar with the random total redesign that occurs out of nowhere. I mean, that could be a sign of the developers at one place getting laid off and them hiring a new company. It could be any number of things that happen. So it's an unstable environment to work in as well. So let's say you want to be an indie dev. You want to make a profitable app as an indie. In 2010, you had a pretty good shot at being a profitable indie dev. Today, you can tell I wrote this slide more than a month ago. Probably not going to happen. If you're going to be a mobile developer, or if you're in this class at least to make an app, do it for fun, do it for your resume, don't do it for the money because you're probably not going to make any. That said, all the negatives aside, doing this is a really great resume pointer. It shows that you're able to make a finished product. Despite all of the hurdles that I mentioned, this is still one of the fastest ways to make a fully functioning finished product that you can actually show people. Web also gives you that opportunity, but mobile gives you that opportunity in a way that lets you just show the interviewer your phone or show them the link to the App Store and let them see what it does. It's impressive anyway, and so it's definitely something that I encourage you to do. Make an app that's impressive so that you can show it to interviewers. You can put it on your resume. You can put a link to it. It's one of the lowest friction, best ways to demonstrate that you're a real developer with a wide skill set. Full stack. You can make a front end. You can make a back end. The mobile development involves all of that. So, especially for those of you who need the resume bullet points, which is probably almost all of you, I think this is still a great experience to have. So how about those cross-platform development environments that I mentioned? So things like Xamarin. Microsoft bought Xamarin when Windows Phone died, basically, and they paid almost $1 billion for Xamarin. And then they forgot they bought it or something, because then they didn't do anything with it. And the irony is that I don't even think the Windows apps like Word and Skype are made with Xamarin, if that lets you know how little Microsoft had faith in Xamarin. Xamarin is just as terrible as mobile development. It has pretty much all of the problems that we already described. For example, Xamarin Forms, which was once the main mechanism for doing front end on Xamarin, basically setting up your UI and everything. They just announced either this year or last year, that's going to go away. We're going to use this new thing now. Forms is out, new thing's in. You basically have a year to make the transition. So same kind of behavior that you get where you have major language and platform transitions on almost an annual basis. Xamarin has the added problem of being pretty much a ghost town online. Not a lot of people use it, and it seems like the people who use it are mostly enterprises, and they don't tend to respond to questions on the internet. So you have a very minimal number of tutorials, answers of any kind. Sometimes what you want to do is a generic C# question, and you can get answers because Xamarin's part of the .NET stack in general. But if you want to do something Xamarin specific, you are often going to be out of luck finding any reference. And while Microsoft's documentation is okay, it's not going to solve every problem for you. So a lot of the time you're going to be on your own, and that's rough. React Native and Flutter are both alternatives for doing your front end on Android. React Native has become super popular, probably about as popular as Android native development. So if you want to do your stuff in React Native, more power to you. The great part about React Native and Flutter is that they're both web frameworks. They're both web front ends as well, and they work on iPhone as well. So you basically get to design the UI once for mobile, web, and iPhone. Obviously, that's the big selling point on these and why they've gained so much traction. If you want to be a web developer, that helps a lot. If you're an astute observer of the tech industry, you might notice that Flutter is also a Google property, and that Google has actually used Flutter to develop some of the apps that some of the Google apps that come with Android or that you can download from Google. I don't remember which, but I know some of them are Flutter based, which leads to a funny question. Is Android's future going to be all Flutter? Are they going to get rid of Android front-end native? Some people think they are. Some people think no. Google is such a massive company that the Android team and the Flutter team are separate, and they might not even talk that much. So it's possible that they just continue working in different directions, and maybe at some point one of them will get the axe. Who knows? Google is pushing Flutter pretty strong in the web space, so at some point maybe it'll be mandatory in Android space too, and then you have to migrate all of your front end to Flutter again. Yay! I mentioned that Microsoft doesn't use Xamarin for a lot of their own apps. They actually use React instead. Again, kind of a funny thing. Just as funny as Google not using native Android front-end development in lieu of Flutter, but okay, I guess you can compete against yourself sometimes and see what turns up. One of the main reasons that React Native and Flutter are popular, though, is it's web developers who find it easier to use than having to relearn everything for Android, so they find it to be an easier path to working on mobile. So if you've got experience developing for web, which some of you might have because you've taken that advanced web design course, you might find these to be easier than working in Android natively. Both React Native and Flutter, I think, have relatively easy plugins to install on Android Studio. I'm not going to show you either of these because we already have two different front ends we're going to look at and it would take too much time. But they're both pretty good, so by all means, do it in one of these if you're interested. So a couple other rays of hope, besides the fact that this is going to be helpful on your resume and generally improve your skills, is that game development on mobile is mostly better. It sidesteps a lot of the problems I talked about. The engine companies like Unity and Unreal and whatnot, they handle dealing with the operating system and all those ever-changing APIs on your behalf. So you don't have to worry about any of the silliness that is Android. You just get to write in your plain old C# or C++, depending on the engine. They're usually in one of those two languages since those are the popular ones in the games industry. And you just get to write in those languages as you have for decades and as you probably will continue to do for decades, which is wonderful because you don't have to keep learning new languages and think about all that weird stuff. And it's funny to think about it, but for many people, especially those outside of this profession or outside of any computer profession, the strongest computing device that they own is their phone. Most people that own a computer own a cheap one, whereas people are happy to drop $1,200 on an iPhone, and the iPhone's performance is quite high indeed, as are flagship Android phones for the most part, but mobile performance in general is quite high indeed. Don't underestimate mobile devices. They now come with 4 or 8 core CPUs regularly, 8, even 16 gigs of RAM is on the horizon soon. You've got a lot of built-in memory. Phones are not nearly as silly and slow as they once were. So generally, most people have a phone that might perform even better than their laptop. And these engines give you the ability to deploy to PC as well as Android and iPhone at the same time usually, which allows you to shorten your development a lot by not having to develop for all those different platforms separately. So game development, a little bit better than the others. There are still occasions where you have to deal with the silliness of the mobile platforms, but it's a lot less headachy, I would say. Okay, so got one more slide. Forgot about that. So should you learn mobile in 2021? Honestly, better skills to pick up. You could learn web instead. You could learn machine learning, databases, or any number of other cool tricks instead. But mobile's probably more fun than those things. At least you get to make some nifty thing. For all the frustration, you definitely get to make something that actually serves a real purpose. Kotlin demand is going to probably continue to grow as companies are forced to port their apps over, and Kotlin is a relatively rare skill, so having that on your resume can be quite helpful. Mobile apps are great resume builders in general, as I mentioned, because it gives you something you can show to interviewers quickly. Even with all of the problems I described, again, mobile's still one of the easiest platforms to get a finished product out that serves a purpose. And as some of you have already mentioned, there's all this stuff that you don't know. Well, mobile will teach you a little bit of all of it, because all of that stuff is in Android to some extent or another. Factories and design patterns and network use and all that stuff is all over the place in mobile, and usually in a very simplistic way that lets you learn it with kind of lower stakes. Of course, if the road is easy, the destination is worthless, right? So mobile's worth learning maybe just because it's hard? I don't know. All right, any questions for the last 10 minutes? Anyone got any questions? While I field your questions, I'm going to see if I was right about my wager and try to copy in some of that fragment code that they were talking about and see how well that works. So any questions in the last 10 minutes about Android development? Let's see, what do they want me to do first? I gotta go to build Gradle. I've got 2 build Gradles. Which one do I pick? Okay, I'm gonna go with the Kotlin version. Do not place your application dependencies here. They belong in the individual model build.gradle files. All right, let's go there. Dependencies. I'm going to use this one. And then I'm going to try to compile and see what happens. Let's plug my phone in first so I have a device. All this for a demo. So, no questions? No one wants to know anything about Android development? How does everybody feel about Android development? Are you excited for this wonderful platform and all of its eccentricities? Excited to develop an app in it? Will this compile? More scared. Okay, that's fair. Let's do a poll. Check out how long it takes for that build to run. Again, that is the Ryzen 7 PCI Express 4 SSD speed. Alright, it finished building. It did run. It is actually on my phone. I will find a way to beam my phone to the main screen, by the way, when we're actually doing the development later on. So most people are excited. That's good. Alright. How do I make a fragment class? So to create a fragment, extend the Android X fragment class. Let's try it. New. I guess I got to go to fragment and make a blank fragment. I'm going to call it test fragment. And I'll make it in Kotlin. Where's my test fragment? Well, look at all this extra stuff that it added to my test fragment. So what did I do wrong there? It said to create a fragment, extend the Android X fragment class, and override its methods to insert your own app logic. So I definitely have some of this stuff happening. You can see at the top, that part's the same. r.layer.example fragment, I don't have that yet because I haven't made a layout for my example fragment yet. And then I have all this other stuff here. What's all this stuff? What's all this stuff? Who knows? There's actually already a fragment in this app somewhere, so this isn't the first fragment here too. Nothing depreciated so far though. So to declaratively add a fragment via the active layouts XML, use a fragment container view element. That's simple. Here's an activity layout containing a single fragment container view. Where do I make that? All this and more when we do the fragment lesson later. I just wanted to demonstrate how useless this documentation is to somebody who's a beginner, let's say. I mean, I guess fragments is a bad place to start, so maybe this is an unfair example in that sense. But just the fact that you have to go through all of these steps, there's no copy and paste this code to get started kind of deal, and this is true of most places in the Android documentation. So what I'm going to do for the most part in this class, I'll show you the Android documentation. I'll show you how I reason my way through it with what I've learned from memory. Do I have the process for making a fragment memorized? Absolutely not. It's changed on me a few times, so I'll probably get it wrong a few times as well. But eventually I'll show you how to make a fragment and all of that good stuff. So I'm going to get rid of all these for now. Okay, well, if there's no more questions, I think that's it for today. Here's my test fragment that they basically asked me to make there. No, that's gone. Okay, well, I tried to go forward in the browser, and it didn't even take me to the page I was looking for. It took me to a search page, so that's fun. Good stuff. All right. So, hopefully everybody has Android Studio running by next week, have their device connected. Message me if you have any problems with that. Next week we'll get into making a basic application and all that good stuff. All right. Thanks for tuning in, guys. See you next week.